Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel. Let's have a look at this past paper question. Paper 1, Physics IB High Level, Time Zone 1, May 2023, number 15. The same question appeared number 18 in paper 1, SL, the standard level paper, the same session, May 2023. Two opposite charges of magnitude Q and 2Q, so they are positive charges, okay, are fixed as shown. At which position is the electric field due to these charges equal to 0? So what do we have here? We have two positive charges. Let me just confirm that by adding kind of like just a plus sign here to confirm the both of them are positive, right? And the magnitude in Coulomb, let's say the SI unit of charge or quantity of charge is Q, okay, and the other one is 2Q, which means double the magnitude. And we have four positions here, A, B, C, and D, and we need to find at which position electric field equal to 0. First of all, I have a comment, like kind of lack of accuracy here in the question, and I need to share it, but I see it all the time. I just want to comment on that. First of all, there is a big difference between electric field and electric field strength. Okay? Unfortunately, in many questions in IB, they don't differentiate that. They mention electric field, but they mean electric field strength. Okay? But there is a difference. What is the difference? Electric field, so let's say we have a charge here, in the schematic here below, right? A positive charge, just to match the question. And I'm going to call it Q capital. Now this charge here creates a field or the region around the charge in which this region here, if I bring a small test charge, it would experience a non-contact force. So the region around the charge itself where a small test charge would experience a non-contact force is called electric field. That's it. But electric field strength, this is the physical property, that describe this electric field. Okay, so just for the sake of accuracy, unfortunately, many questions mention electric field equals 0, but they mean electric field strength. However, if you see definition question, okay, you have to stick with whatever you see. If I ask you to define electric field, so the definition, as I mentioned, just the region. But if I ask you to define electric field strength, I will show you now. And let's remember together, what do we know about electric field strength? So what is the idea here? The idea here, I'm going to bring a small positive test charge, okay? And I'm going to put it here inside the field. Let me put it here maybe, okay? And I'm going to call it Q small. So this test charge would experience a force or electrostatic force due to the existence of another positive charge, right? And in this case, we can use Coulomb's law to quantify this force. So Coulomb's law says electric force equals to Coulomb's constant multiplied by Q capital Q small divided by R squared, where R is the distance between the two charges. Okay, so this is force, Coulomb's law, right, between these two charges, and that's why you see the electric field strength here, or electric field direction, is pushing away this Q, right? So this is typical, electric field radial and away from the positive charge, as if you imagine you put here a test positive charge here, so it's going to be pushed away, right? And that's determine the direction of electric field due to a positive charge. It is radial and it is away from the charge. Now, if you divide both sides by small q, right? You divide both sides by small q, So I have K, Q, capital Q small divided by R squared, but then I'm gonna divide by Q small. So this Q small will cancel out. And F over Q, we are going to call it big E, which is electric field strength. So electric field strength is now KQ over R squared. It has nothing to do with the small q. It depends only on the charge that creating the field and the distance. Okay, at a distance to a certain point in the field. So electric field, so force in Newton, quantity of charge in Coulomb, electric field strength in Newton Coulomb minus 1. So by definition, if you are interested, electric field strength by definition is the force per unit of charge. Is the force per unit of charge, right? Experienced by a small positive tested charge in a certain point or at a certain point in the electric field. That is the definition, Newton per Coulomb or Newton Coulomb minus 1. Now, that was just a quick introduction to tackle this question here. So now the direction is very important. Say, okay, now as you see here, electric field strength is a vector quantity, right? So because there is always a direction vector, right, representing the field or the field strength. Okay, so let me use different colors here for the fields due to Q and to Q. So I'm going to use red for Q, for example. Okay, so I'm going to say, okay, this is my red charge here. And let's say, for example, at point A, there would be an electric field going this way due to Q, because as I mentioned, you know, the electric field strength direction is away from the positive charge. And this is really the whole point of this question here, right? Now, we have a positive charge here again, right? 2q, but the distance is much bigger. So basically, electric field strength is inversely proportional to the distance and directly proportional to the magnitude of the charge, right? So I would say, okay, let me now keep it black for the 2q, and I'm going to draw another field strength. It will be also in the same direction because it is positive charge. Okay. So now electric field strength is a vector quantity. So we say, okay, at which position is the electric field equal to 0? So that means at least I need to see opposite directions, right? Because the vector sum here of these two vectors will be even bigger, right? So we can exclude right away, you know, option A from the beginning because they are both in the same direction. If you look at option D, right, the same thing, right? We have red towards away from the charge due to Q, right? So due to Q here, I'm going to draw a small maybe electric field because it is far from the charge and it is also only Q, not 2Q. So compared to, it's like half Q, half the other charge, right? But then I'm going to draw again one electric field due to the 2q, but again in the same direction because it is away from the charge and it is closer to 2q. That's why I draw this a little bit bigger. Okay, it's not really the most important point here. The most important is to know where the point is 0. Okay, again, so D is out. Why? Because both of them are in the same direction. The vector sum will be even bigger. So now even really we are between B and C. So now let's really try to use our intuition and our relationship between E and Q and R, right? So the bigger the Q, the bigger the field strength, the bigger the distance, the smaller the field strength, right? So if you look at point C, for example, right? A point C, it is closer to 2Q, right? So it will have, you know, electric field strength at this point, at point C, let's say going this way. Let me just 2Q, so it's black. Sorry, let's just change to black. So it's going to go this way, right? Now, at point C, let's continue. So at point C, here we have another field due to Q, but it's going to be that way. right? Now, what is the field in red now compared to the black? So we have now C is further from Q, and Q also is as a magnitude smaller than 2Q. So there's no way the field strength will be equal. It will be even smaller at point C due to Q only. Make sense? Right? Because point C here is further away compared to 2Q, right? And also Q here is smaller. So anyway, this red line here at this red field here at point C has to be smaller than the black one at C. So we left with really the final answer is B. So B here, again, if you look at B, you have, okay, closer to Q, but Q is smaller as a magnitude. So, and then that will compensate, you know, the bigger distance from 2Q, and 2Q would be bigger due to the magnitude of the charge. Okay, so the final answer for this question is B. I hope it was helpful. Okay, the bottom line, electric field strength is a vector quantity, right? And it is away from the charge if it is positive charge. Thanks for watching and have a nice day.